Hi, I'm Karen Kinsella. I'm a chemist at GZA GeoEnvironmental. I'd like to invite you to my workshop at the National Groundwater Association Expo and Annual Meeting this December in Las Vegas. Groundwater pollution is a serious problem throughout the world. Mother Nature can heal herself, but we can help her do it faster by enhancing natural remedial processes. All life forms get energy from electron transfer or oxidation and reduction reactions. Chemicals that accept electrons are reduced because electrons are negative, and chemicals that donate electrons are oxidized. So this electron cycling process is called redox, for reduction oxidation. And groundwater redox controls everything from bacteria eating oil spills to iron minerals capturing chromium from leaky plating baths. So here's an example of how we can manipulate groundwater redox to clean up perchloroethylene, also known as PERC or tetrachloroethylene. PERC is a man-made chlorinated solvent. It's used in dry cleaning and metal parts degreasing. And PERC and its closely related sister compound, trichloroethene, are the most common groundwater contaminants in the United States, polluting as much as a third of our groundwater here. So in oxygenated groundwater, some PERC can evaporate, but very little can be degraded by bacteria. If there happens to be a leaky oil tank somewhere near your PERC spill, you're in luck, because what will happen is bacteria will eat the oil, and as they're doing that, they consume oxygen and other electron acceptors, reducing the redox potential in the groundwater. When the redox conditions get low enough, other kinds of bacteria will actually feed on the degradation products from the oil, and they can actually breathe the PERC just as if it were oxygen. And in this way you get both the oil and the PERC cleaned up at the same time. Now, organic rich sediments or peaty soils can naturally remediate PERC, but to speed up this natural degradation, we can inject feed or food grade additives like sugars and vegetable oils. But what about heavy metals? Things like chromium and lead that can't be degraded like organic pollutants. So hexavalent chromium, for example, is a highly toxic form of oxidized chromium that's widely used in pigments, wood preservatives, and metal finishing. Think muscle car chrome or your neighbor's Harley Davidson. Another example of groundwater cleanup by redox manipulation uses a trench-style underground permeable barrier that's filled with tiny iron filings mixed in with sawdust or sand. And what happens as the groundwater contaminated with chromium moves through that underground barrier, the iron particles donate electrons to the chromium, reducing it and preventing it from being water soluble. Now this reduced chromium just is immobilized in the trench because it can't move with the groundwater anymore. Now, you might seem like the iron would eventually be used up. We've only put a limited number of these little iron filings into the trench, into this underground trench. But what they found is that the longevity of these barriers is much greater than would be expected. And this enhanced longevity is very likely due to chemical and biological reactions between the iron corrosion products and native bacteria and native minerals. So this interaction between the biology, the geology, and the chemistry is one of the many ways that we can manipulate nature to accelerate groundwater remediation. So if you're at the Groundwater Expo in December, come to my workshop. I believe you'll leave it knowing what you don't know. And when we can ask focused questions about the biology, the geology, and the chemistry at a site, we can aid Mother Nature in cleaning things up, and we can also have very efficient, cost-effective solutions. So hope to see you in December.